Hello everyone and welcome to this demo presentation. I am Fabrizio Matarese, Research Fellow at the Istituto di Scienze e Tecnologie dell'Informazione Alessandro Faedo of the Consiglio Nazionale delle Ricerche. I present a work done together with Dr. Massimo Magrini and Dr. James Magnavacche, and in collaboration with the Carlo Collodi National Foundation, which manage the park and the square where the augmented reality experience comes to life. This presentation illustrates the resolution of a problem encountered in the development of the Vero project, which aims to create an augmented reality system in the Pinocchio Park in Collodi, in the center of Tuscany. The problem in question is related to the stability and the robustness of recognition and tracking of the image target located in an external environment, the mosaic square, and therefore subject to change in lighting and environmental occlusion. In recent years, more and more cultural institutions, museums and archaeological parks have equipped themselves with augmented reality systems to enrich the visitor experience and to offer assistance that communicates information on the cultural side, overcoming cultural and temporal barriers. Of all the new digital technologies, augmented reality has turned out to be one of the most promising in the field of cultural heritage. I have divided the presentation into 4 small areas. The first will briefly illustrate the environment, namely the square of mosaics in the Pinocchio Park in Collodi. The second area will focus briefly on the prototype development process. The third will deal with exposing the problem and illustrating the literature relating to the resolution of a similar problem. Fourth will finally show the solution adopted as part of the Vero project. Let's start from the setting. The mosaic square is the work of architects Renato Baldi and Leonello De Luigi and the artist Venturino Venturi, who oversaw the mosaics that cover the flooring and the walls that form the square. The Piazzetta dei Mosaici, or Magic Square as it was defined by the press, consists of a square of 30 meters on each side, paved and closed by shaped perimeter walls, on which an evocative re-enchantment of Pinocchio runs through flashes of famous characters and episodes of Collodi novel. Now let's talk briefly about the prototype development process. The tools we have used for development are Unity 3D as a game engine, which in addition to considerable powers offers features such as versatility and cross-platform compatibility. C#, which is the language of Unity scripting system, which is object-oriented, and as augmented reality libraries we have opted for Air Foundation, a framework that includes ARCore and ARKit features and that allows the distribution of the same project on multiple platforms. We have divided the functionalities of the prototype into 2 macro categories, Explore mode and Play mode, plus the possibility of taking photographs with elements of augmented reality and a mosaic effect filter that imitates the expressive style of the square. Here we see briefly summarized the features of the Explore mode, and here we can see the final animation of the shark that constitutes one of the experience of augmented reality. The game mode consists of 2 scenes. The first, a tutorial, illustrates the rule of the game, which frames the episode of the story of Pinocchio represented on the mosaics, following the chronological order of the story, and the actual game scene, at the end of which the user can also see the score achieved based on parameters such as time spent, number of errors, etc. Filter mosaic effect allows you to take a picture and apply a mosaic effect to the image with the ability to adjust some parameters. The software architecture we used to set up the augmented reality experience is briefly illustrated in this image. We used a specific tool to create the reference library in a way that was already optimized for the recognition system adopted. Then, for the experience of augmented reality itself, we used features such as plane detection, anchors, and image tracking. The algorithm adopted can be described by the following pseudocode. Now let's move on to the most significant problem faced and how the scientific literature has dealt with it previously. As we can see in this image, the lighting of the mosaics used as reference image is not uniform, and this makes problematic the recognition and tracking of the same image inserted in the XR reference library. This problem has been addressed numerous times in research in recent years. Different authors have addressed the problem with different approaches and different technologies. In these slides, we have a brief overview of some previously adopted solutions. Some authors proposed a solution based on a set of images taken under different lighting conditions. Others use GPS coordinate and location tagged image to improve the robustness of the system. Others proposed a solution in which they replaced the live camera view with a previously captured panoramic image, a method called indirect augmented reality. Other researchers use a solution based on a geolocative raycasting technique. Our solution is based on a system that integrates already used methods like use of multiple images with new solution, like the decomposition of the target image into 2x2 blocks to achieve an ideal balance between robustness of the recognition system and overall performance. Multiple target image and crop tool. These are the two main features that have enabled robustness in our recognition system. Adding more image taken under different lighting conditions to the reference image to the reference library increased stability but was not enough for the standard we had set. So we developed a method that decomposed the individual image into a set of 2x2 blocks to further increase the possibility of recognition while minimizing the impact of changing lighting and environmental occlusion. The crop tool is a tool that automates the process of decomposition of the target image into blocks and also automatically allows the correct positioning of the content to be activated through recognition. The algorithmic approach of the crop tool can be described in the pseudocode as follows. Following the Bernoulli law, the probability of the recognition of exactly k blocks is expressed in the following equation. We did some on-site tests following this instruction. 2x2 block matrix reference library, 21 mosaics to recognize, 2 Ks with uniform light and light with shadows, and 30 seconds max time used for recognition. The results of the test carried out were in line with those we expected following the equation illustrated previously. In this video, the recognition of single blocks of images placed in the reference library is highlighted with standard shapes. The proposed solution proved reliable and robust and gave extremely positive results, granting a steady image recognition on every mosaic that adorns the square, The crop tool GUI facilitates the preparation of the multi-block image target, and the algorithm provides a more practical solution requiring fewer images for each artwork than a full-fledged library of all possible instances of the full mosaic surface. A future version of the tool is currently under development. This version will automatically exclude from the image library the non-relevant blocks, measured with the Arcore and Arcade tools. Thanks for your attention.